Alright, for the final appendix lesson for your summer homework, at least for this half of the summer homework, we are going to do with rationals. Those have to do with fractions. We'll be starting with this example, but before we get there, let's review how to do fractions. If you can understand how to do regular fractions, regular numbers, then this will be a lot easier. So first would be adding fractions. So if I had a half plus 4/5, I can't just add these. This would be wrong. I do not get 5/7. So don't just do that. Actually, I don't want to erase all of that. What I need is a common denominator. I need these to be broken up the same way. So if I think of this as this is the number of ways my pie is cut, and this is the number of slices I have. In order to add these, I need to cut my pie the same way. So the same way in this case is going to be into tenths. So if I cut this pie into 10 slices, well, how many slices would be half of a pie? Well, 5 slices. So I multiply top and bottom by the 5. And if I cut this pie into 10 slices, now this is a plus, so I'm going to have a plus here. If I cut this into 10 slices, well then how many slices would I have that's equivalent to 4/5? So if we just think of our pie, actually let's make it a cake. That'll be easier. So 1, 2, 3, 4. Alright, here's my cake, long slices. Alright, so 4/5 would be up to here, right? That's 4/5. Color this in. Okay, so I have these dividers right here, and I want to cut that into 10 slices instead. So here's my extra slices. Alright, let's count 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then 9, 10. So I have 10 slices, 8 of them. Okay, so I expect an 8 here. Well, how did I get that? Times 2. Times 2. Alright, and then I can go ahead and add my numerator, and I get 13 tenths, which makes sense there. Now, if I'm subtracting, it's going to be the same basic idea. If I have, say, 5/3, and I'm subtracting 8 halves, alright, that's actually 4. Yeah, let's do that. Let's 4. I'm going to subtract 4 from that. I need a common denominator. Now, the denominator on this is a 1, so I want to write that. And then my common denominator, then I'm going to cut them into 3 equivalent slices. So this numerator stays the same. And then subtract. Now this is now a 3, so times 3 times 3, and I get 12. 5 minus 12 is -7/3. Alright, multiplying them is actually easier. So if I had 4/7, say, times 14/15, okay, I can cross cancel. I can only ever cancel through multiplication. If there's addition or subtraction or division, I can't do what I'm about to do. So I can cross cancel. I can divide those both by 7, so there we go. And top times top, so we're going to do top times top, and bottom times bottom when we're multiplying fractions. So we get 8/15, because 4 times 2 and 1 times 15. If I have mixed numbers, if for some reason we have that, we're going to want to make them improper. So if I had 1 and 2/3, and I'm multiplying that, say, by 2.5, I'm just going to quickly change this. I'll use the trick rather than explain it. Times, add. So 3 times 1 is 3, plus 2 is 5, so 5/3. If I were to divide this, top divide bottom, I would get that. Times, it's going to be 5 halves. And I don't need a common denominator when I'm multiplying. I can't cross cancel, so 25/6 is the final answer right there. And lastly, division. If I say we're dividing a half divided by, say, 3 halves, I'm going to KFC, keep, flip, change, which is going to make this a lot easier. So I have a half times, I'm going to flip this second fraction, and I changed from division to multiplication. Because division and multiplication are inverses. If I flip the second fraction and switch to multiplication, it's equivalent. So I'm going to cross cancel, and 1/3. Now sometimes what's going to happen is you're going to be trying to be tricked into canceling before. Like if I look at this example right here, it's very tempting to go ahead and cross cancel these 2's, but remember, like I said earlier, the only time I can ever cancel is through multiplication. So I need to KFC, keep the first fraction, flip the second fraction, and switch to multiplication. And see, I see nothing cancels. I can't cancel sideways. Cross cancel has to be diagonal. So I'm going to top times top, bottom times bottom, and 5/4 is good right there. Alright, so now let's take a look at our pre-calculus problems now that we have that done. When we're doing rational, and we're going to follow all of the same steps that I just outlined with numerical fractions as with these algebraic expression fractions. But an additional step that we're going to have is we're going to have to factor. So I'm going to want to factor everything first before I begin working. So this slash does mean to divide, so if you see that in your textbook or anywhere, that means to divide. So I have a fraction. I'm going to factor this numerator, and remember the first step of factoring, check the common thing, and I can factor out an x in both of those. So an x comes out and over, and this has no common thing, but it is the difference of perfect squares, so it's relatively easy to factor. And then I see now I don't have an operation. I'm not adding anything, subtracting anything, multiplying, nothing. I just need to reduce this fraction. So I can cancel there, and I have x over x plus 3. And that is this fraction reduced. So if you see you always have to reduce your fraction, so I've reduced it. And now what we want to think about is the domain. And the domain is where this is defined for x, or whatever variable we happen to have. So where is this okay? And rather than answer this question, I like to answer it, well, where isn't it defined? Where is there a problem? Well, you can check this on your calculator, but I can't divide by 0. So if I had 1 divided by 0, I'm going to be thrown an error of some sort. If I do, however, 0 divided by 1, I'll go ahead and get 0, because I take 0 things and divide them into one group, and each group has 0 things in it. But this doesn't make sense. I have one thing and divide it amongst 0 people. That doesn't make sense. And the reason is because we actually get infinity here, and you can test that if I did 1 divided by 0.00000001, and I just kept on making this closer and closer to 0, we just keep on getting a larger and larger number. So that's why we can't do that. So anyway, I'm asking this question, well, what's the domain of this? So I'm going to look at my denominator, I'm going to say, well, x plus 3 then cannot be 0. Because if this denominator is 0, then the whole thing's all messed up, and I get that error. So I'm going to solve this, but I have a not equal. X cannot be -3. So there's a lot of ways to write the domain here. I'm going to write it domain of x such that x is not -3. Okay, so that's our domain. And we can write it however we want. We can put it in brackets, but that's our domain. We won't talk about range just yet. We'll save that for later. Alright, so now I have a bunch of fractions just to reinforce that whole idea of how we do these if we have numbers. So I can cross-cancel this multiplication, cross-cancel that. In fact, I'm pretty sure questions like this are the first ones in your summer homework for this section. So we get a 2. Subtracting, I can't cross-cancel in subtraction, so I need a common denominator. And in the case you weren't clear how I was getting my common denominator, I was looking at my 2 denominators and thinking of the least common multiple. Least common multiple is 15 there. So multiply that one by 3 and that one by 5. 18 minus 25. And that will be -7/15. Right here, keep flip change, so I have 6/5 times, that should be a 3/5. No canceling, and so I get 18 out of 25, and that's good. Alright, right here, I have a bunch of addition and subtraction, and remember when I'm doing these, don't freak out, just factor first. We need a common denominator, just like with our numerical fractions, and then we're going to combine our numerators. So that's what we're looking to do. So I can factor this denominator, I can take out that x, and I can factor this denominator, difference of perfect squares, and I look at all these denominators and I think, well, what is common between all of them, or what is common, or what do I need? Not necessarily what is common. So I see an x in this one, so I'm going to definitely need an x. This one has an x. I don't need another x because I've already counted this one, so that's good. I have an x minus 2, so I need an x minus 2 in my denominator. And this one has an x minus 2. I don't need to count it again, I've already got it. And I have an x plus 2. Now, I look at my denominators and I think, well, what is this denominator missing? Well, it's missing the x plus 2. So I'm going to have 2 times x plus 2. Now, why am I doing this? Well, I would need to, like over here, when I was getting my common denominator, see, I multiplied that one by 3, get my 15, multiply that by 5, get my 15. And notice I rename my fraction the same way, top and bottom. So I'm doing the same thing here. I'm renaming the denominator of my fraction, so I need an x plus 2. So I multiply top and bottom of this by x plus 2. I'm just shorthanding it here so I don't have as much to write. This has the x already, so I need the x minus 2 and the x plus 2. Minus. Now we're going to need to be very careful with that minus sign, and we want to extend this, make sure we have it all. And 3, and now we're missing our x. We need an x down here, so x. Alright, now I'm going to start the process of simplifying this. Now I'm just going to work on the numerator for a little while. I see that I'm going to distribute this 2. So that's done, plus. Now I want to be very careful when I do this. If this were a minus here, there's an awful lot of mistakes that happen with not distributing it. So I want to make sure I put all of this in parentheses when I multiply it out. And remember how we do this, x times both of those, negative 2 times both of those, and combine. And then in the end, after I'm done with that, I'm going to get x squared minus 4. Now, if this were a minus here, see, if that were a minus, then that would distribute, this would be a negative x squared, and that would be a plus 4. So that's why these parentheses are very important right there. And now I'm just going to start the process of simplifying. There's nothing to distribute, and I have a 2x minus the 3x, so negative x. I do have this x squared, so I'll put it in order. And then 4 minus 4 is 0. And then I have my denominator. Now remember, we need to always, we might think, oh yay, I'm done. No, not so fast. I do want to check the factoring. If I can factor this numerator, I'm going to go ahead and do it. So I can factor out an x. And we see here why I did that. Because I can actually reduce this fraction. These x's cancel. So my actual final answer reduced is x minus 1 over x minus 2, x plus 2. And that's going off the screen there. And now it's informative to think of my domain, just in case we're asked for that. So my domain, this denominator can't be 0, so it's actually pretty fast to get. My domain is x such that x is not 2 or negative 2. I can't have those. So there we go. Domain. Alright, way complicated. So this means to divide. And I could go ahead and combine the numerator, combine the denominator, and then go ahead and divide, because that's what this fraction board means to do. That's going to be the long way. I actually want to, if I can, to clear up fractions. Now, notice in class, over the years, you've heard me say clear the fractions, and that's only if we really have an equation. I don't have an equation here, but I can do a mathematical trick. I'm going to do a squared b squared over 1 all over a squared b squared over 1. And the reason I'm doing this is actually a 1. If I were to reduce this to be the 1, it's like multiplying by 5 over 5. This reduces to 1. I can multiply this by 1 without actually changing its value. And now I can distribute this. Now where did I get this a squared b squared? Well, I looked at all of my denominators. And I can do it one step at a time if I want, but it takes a long time. I look at all my denominators and I want to think, well, if I were to get a common denominator, what would it be? And it'd be this. So I distribute this to each thing. And in the first thing, the a squareds will cancel. So I have b squared minus, and then the b squareds cancel on the next one, so minus a squared. all over, and then this distributes to both of these. So I have one of the a's will cancel, so I get a b squared, and then one of the b's will cancel on the other side, so minus a squared b. And now I'm going to factor. So I can factor that. That's the difference of perfect squares. B minus a, b plus a. And I'll factor this. What's common? AB. So I get a b minus an a. And I see that I can cancel those and get b plus a. I could write it in a different order. I probably should. So a plus b all over ab. And that's fine. That's good. Now, a cannot be 0, and b cannot be 0. That's part of this thing. Notice I have two variables in that case. Alright, more of these. Actually, notice the same denominator here, so I already have a 9, so I get a 15. And then I can reduce this. I can divide top and bottom by 3, and I get 5/3. Here I can cross cancel, so I will. I can divide these by 2, divide these by 3, and I get 30 over 77. And here, keep flip change, so 2/3 times 5/4, and we can cross cancel here. And 5/6. Always good to keep in mind, if we can do this, those lay out the steps for doing the more complicated ones. Alright, more of these. Now I'm asked here to find the domain. So I tacked on this y equals after the fact, so just because to make it a function. So this one, let me rewrite it. Find the domain. So I like answering that question, are there any problem areas? Well, I don't have a fraction, and it seems to me if I think of any x's to put in here, like if I think of -2, everything seems to look like that would work. If I put in 100, seems to work. So I'm going to say that the domain for this one is x such that x is the real numbers, and I can just put an r there. So that's easy. This one's tricky. It can be 0, but it can't be negative. Okay, so I'm going to say that x minus 4, this thing in here, that's going to have to be bigger or equal to 0. Okay, if it gets negative, then we have a problem. So that means x has to be bigger than 4. So when I write my domain, I'm going to say the domain is x such that x is greater than or equal to 4. So notice how I did that a little bit different than the not equals. X is bigger than something. And that's typically the case when we have a radical. Now, if this were an odd root, if it were 3 as an index of 5 or 7, then actually we have all the real numbers. Alright, this one is a rational right here on the right. And so I'm going to look at my denominator. I'm going to say x minus 1, that can't be 0, or I have a problem. So I'm going to solve that. X cannot be 1, so I say my domain is x such that x is not 1. Do my little squigglies. Alright, this one. I'm going to have to factor first. So I don't have a lot of room, but I'll go ahead and my numerator is not factorable. I can factor out an x here. So now I have two cases. I have this piece and I have this piece. So x can't be 0 right there. And this x plus 3, that also cannot be 0, which means x cannot be -3. So my domain of this one is going to be, I'm going to put it over here. Domain is x such that x is not 0 or -3. Right? This one. The x squared is not a problem, but I see I have this x to the -1, and I need to remember that -1 means move down. So I have 1 over x. So this is going to tell me that my x cannot be 0, so x is not 0. Alright, simplifying these. So first I'll simplify the 18 over 15. I can divide those both by 3. So I get 6 over 5. And then rules of exponents, I subtract those, I get an x squared. That's in the numerator. Well, why? Because there's more x's up here. And also 3 minus 1 is 2. And suppose I had it the other way. I had 18 15ths and x and then x cubed down here. There's two ways I can think of this, both of which I'm going to reduce my fraction. I can think of it the same way as I did over here with 3 minus 1. So in this case it'd be 1 minus 3, which is negative 2. And if I think of it like that, it's always going to end up in my numerator, and then at the end I'm going to move it down, x to the negative 2. The other way I can think of it is I can just be like, alright, I have more x's down in my denominator, so when I do subtract these, it's like this. I have 3 x's at the denominator. That one cancels with that one. That leaves 2 in the denominator. So that's the other way to think of it. Whichever works for you is fine if I have that case. But I didn't. I had more x's in the numerator in this case. Factoring. I cannot do this. Some students do this. Oh, x squared. You know, I can't do that. I can not cancel through subtraction. Well, what subtraction? Right there. So this is subtraction. So I need to switch it to multiplication, which is why I'm factoring. So I can factor out an x. And now one of these x's can cancel with that x cubed, so I have x squared over x minus 2. This one does have a domain thing. X cannot be 2 in that case. So there we go. Alright, again, simplifying, I'm going to factor. So y minus 6, you see factoring, very important skill. That's going to come up all the time this year. All the time. Let's see, that looks good. And then I can cancel those. And y minus 5, y plus 3. And my domain, y cannot be negative 3. Now, could y be 6? Like I canceled it, it's gone. We'll talk about that more during the year. That's called the removable discontinuity. But we don't need to worry about that right now. Alright, we have multiplication this time. So I'm going to factor both of those. So I have 3 over x minus 1. It's helpful to put that in a group, minus 1, x plus 1, 9. And cancel. Now, you've seen me do this, and you've heard me say, well, I can only cancel through multiplication, not addition and subtraction. You might be thinking, well, that's subtraction right there, Mr. Kane. Well, I am canceling the entire group, which is completely fine. Which is why we're factoring, to cancel whole groups. We can cancel those. So x plus 1 over 3. And no restriction to this. Our denominator is always a 3. So what would our domain be? Well, x is, notice element, that's what that means. Element. It's a weird E. The real numbers. Reals. Alright. Multiplication. Now these are just going to get progressively harder. Now notice this one. Oh gosh, these are so close to being cancelable. But this one's a negative x and this is a positive x. If they're close like that, that should clue you in on a factoring trick. So we're just going to leave that. We want our highest power of x to be positive. So if I factor out a negative, say a negative 1, that's going to switch this to a positive x. So I'll write that x first, and that'll switch that to a negative 1. And then I can factor this denominator. And I will cross cancel these and the x minus 1s, and I have negative 1 over x minus 3. And again, my domain, x cannot be 3, because then we'd have a problem right there. Alright, more factoring, a little bit trickier factoring. Factor out a y in this one. Remember, always factor out the common monomial first. And see, when I factor out this y, it doesn't become a 0. Becomes a 1. You need to check that. Distribute it back. Do I get this back? That's a good clue whether you did it right or not. This is difference of perfect squares, so I can go ahead and do this pretty quick. And this one's a little bit trickier, but I'm going to take a hint from this because I am going to have a 2 right here. I need a 9. So I'm going to need to get as close to 9 as I can. So I'm thinking when I think of this factors of 5, I'm going to put the 5 right there and I get my 10. I need a 1. See, this is negative, so one of these is going to be negative. If I put a negative here, I get a negative 10, but this is a positive 9. So I'm going to put the negative there. And that should be good. Cancel. And those cancel. and we get y plus 5. Don't forget this y minus 5. And now y cannot be 0 and y cannot be 5, or we have problems in our denominator. Division, key flip change. This is a y right here, so I have 2x times y over 1, top times top, bottom times bottom. Easy. And x cannot be 0. Alright, again, key flip change. I'm going to factor this so I can do that key flip change step at the same time as I'm factoring, just to save myself a little bit of room. Times. So I'm going to flip this. I'm also going to, look, I can cancel those. Okay, so I'm going to get 3y over 2x. And these x's cancel. These y's cancel. And I get 3 over x minus 3 over the 2's did not cancel. Can't cross cancel those, so that's 28. And no restrictions on my denominator, so we're good. X is real numbers. It can be anything. Alright, big kahuna right here. This means to divide. So this is a division problem, so I'm going to keep flip change. So 2x squared y x minus 3. This is squared, so I can do this if I want. And I do want. Times. I'm going to KFC right away. So this needs to flip around. X minus 3. 8 over x. And now cancel. Only cancel one of these, not two. It only cancels one time. 2. Y's. And one of these x's. So I get, see this sometimes hard to see, I get that. I have x, I have that left. Okay, and x cannot be 3. Alright, now we're combining. So we need a common denominator. So I look at both of these. X plus 5, x plus 1, 2x plus 1. Now, what is this denominator missing? The x plus 1. So I'm going to multiply my numerator by x plus 1. Minus. So this is going to be very important with our distributing, because we have a minus sign. This denominator is missing the x plus 5, so x plus 5. I'm just going to work on my numerator a little bit, so I'll expand the top. Notice when I multiply that out, you could say it's distributing. The more pro word is expand. So I'm going to multiply that out. 2x squared plus 3x plus 1. Distribute this negative 3, so negative 3x minus 15. And combine like terms, so 2x squared. 3x's cancel, we get negative 14. Now I can factor out that 2. And this actually is the difference of perfect squares. Well, wait, 7's not a perfect square. You are going to have to factor, like, you don't have to do it for this problem. Let's talk about this. I can factor this. It's this. CY during this school year. X plus 5, x plus 1. So I don't need to worry about this factoring here because there's nothing that really cancels out. So this is good. And then x cannot be negative 5 and x cannot be negative 1. So again, how do I write my domain? Domain x such that x is not negative 5 or negative 1. This is basically how we're going to write our domains this year. Alright, combining, we do have a minus here. We're going to factor. I'm just going to shorthand this factoring so I'm not writing as much. This video is taking a little bit longer than I wanted it to. That's going to stay the same, but I'll just write it again. And x minus 2, x plus 2. So there's my factored. So I look at what I need in my common denominator, because I'm not solving anything. I can't just clear these. So like that, I need that. I have an x plus 2. That one has an x plus 2 as well, and an x minus 2. I don't need to count the x plus 2 and the x minus 2 twice, unless, say, this was squared. If this were squared, then I need it twice. But it's not, so I don't need to worry about that. Alright, so this numerator is missing our x minus 2, and this numerator is missing our x minus 3 and our x plus 2. And this one the last fraction is missing the x minus 3. So I have an awful lot going on in my numerator, which is why I like just draw me a little arrow. I'm going to work on this a little bit. Distribute this 5x. Now I'm going to hold this negative 2. Do not do this negative 2 first. Put parentheses, multiply this stuff out that's right here, and put it in parentheses. That way we can avoid some mistakes. See, we're going to distribute negative 2, which is going to switch all those signs. If you don't put these parentheses, I guarantee to you, you're just going to write minus 2 and not ever distribute it to the other two things. So be careful with your laziness. Don't be lazy. Distribute the negative 2. I'm going to go ahead and combine this negative 4x, take the sign with the term. So 5x minus 4x is x. Negative 10 plus 12 is 2. And I'm going to distribute that negative 2. Well, why didn't I include these when I was combining? Because I still had order of operations, multiply before add and subtract. And now I'll just put these in order as I'm combining. I'm hoping, I'm doing this really fast, so I hope I'm not making a bunch of bonobo mistakes. Does this factor? I don't know. Negative 2x. I don't like that that's negative. Let's factor out a negative. I don't know, I might be wasting my time here. So let's factor out a negative. So 2x squared. I'm just seeing if this factors. I don't know. I need a 3 here. Maybe 7 and 2. 4 and 7. Maybe. Maybe it does. It does. It does factor. Good thing we checked that. So, what does this mean? Well, it means that something cancels. That should be a 2. X minus 2. It means these cancel. Alright, so what's our final answer? I'm going to erase all this. Boom. Final answer in black at the top here. Negative. I can leave that out. 2x minus 7 all over x minus 3, x minus 2. And domain, x is not 3 or 2. Okay. Alright, so now I'm not done, but this is the assignment that goes with this lesson. I am going to do 3 more questions, or 4 more, that are challenging, that are actually more of the pre-calc type that you're going to need to be able to recognize what to do. But this is this should be what should that be right there? I don't remember. Is that a 46? Yes, this is a 46, not a 48. 46 right there. So now you should be ready to do that, or at least you've watched the video to do it. Now I'm going to do a few more, just so that you don't get your undies in a bunch over things that are actually not that bad. So this is one question, and I'm just adding these, and we look at these negatives and we're like, I don't know what to do, freak out, drool. No. Rules of exponents. See, that's the thing that's going to make pre-calc this year difficult, is the amount of overlap of all the topics. So I need to be able to use my rules of exponents in different contexts than just rules of exponent chapter. So I need to move this down. So I get 1 over x, and move that down, 1 over y. And now it's common denominator, xy. What's this missing? Well, a y, so 1 times y is y. And this one's missing an x, so x. So just put that in order, x plus y over xy. And x cannot be 0, and neither can be y. That can't be 0. Alright, another one. X plus y to the negative 1 over x minus y to the negative 1. And, oh no, freak out. Well, if I had a to the negative 1, anything, I would just move that down, right? 1 over a. So I can move this piece up and that piece down. So I have x minus y, and now the exponent is positive, and move that one down, and I have x plus y, and I'm done. That's it. And, well, how do I state my domain here? Well, x, I mean, you probably wouldn't, but really x cannot be negative y. Okay, so these can't be opposite. Say I can't have 4 plus negative 4, like that wouldn't be allowed. But we probably wouldn't talk about domain in that question anyway. Last one, I promise, last one. X to the negative 1 plus y to the negative 1 to the negative 1. Alright, so lots of flipping around. I would deal with this one first, so I'm going to move the whole group down. So x to the negative 1 plus y to the negative 1. And now, well, I move that down. So 1 over x plus that down, 1 over y. And I would get a common denominator right here and go ahead and deal with that. So I get 1 over xy, and this is going to be x plus y in the end. Now I keep flip change, so 1 divided by x plus y over xy, flip, and 1 times anything is that thing, so this is the final answer. And again, x can't equal negative y. Alright, we are done. So what this means is you're going to do this assignment that was right here, and you are 1/2 done after you have done this assignment and the other two with your summer homework for pre-calc.